Chapter 9: Linear Momentum and Collisions. Momentum. Measure of the quantity of motion that an object has. It is a vector quantity. Momentum depends equally on an object's mass and velocity. The momentum p of an object is the product of its mass and its velocity. P equals mv. Impulse. The change in momentum of an object is proportional to the length of time during which the force is applied. If a force is exerted on the lower ball for twice as long as on the upper ball, then the change in momentum of the lower ball is twice that of the upper ball. Mathematically, if a quantity is proportional to two or more things, then it is proportional to the product of those things. The product of a force and a time interval over which that force acts is called impulse and is given the symbol J. The definition is the word is effect of applying a force on a system for a time interval. This time interval is usually small but doesn't have to be. Impulse momentum theorem. An impulse applied to a system changes the system's momentum, and that change of momentum is exactly equal to the impulse that was applied. J equals delta P. Problem-solving strategy of impulse momentum theorem. Number 1. Express the impulse as force times the relevant time interval. Number 2. Express the impulse as the change of momentum, usually m delta v. Number 3. Equate these and solve for the desired quantity. Conservation of linear momentum. Total momentum of a closed system cannot change. The conservation of momentum states that within some problem domain, the amount of momentum remains constant. Momentum is neither created nor destroyed, but only changed through the action of forces as described by Newton's laws of motion. Types of collisions. Explosion. The first possibility is that a single object may break apart into two or more pieces. An example of this is a firecracker, a bow and arrow, and a rocket rising through the air toward space. After the explosion, the net momentum of all the pieces of the object must sum to zero. However, the system will have a great deal of kinetic energy after the explosion. Thus, we see that although the momentum of the system is conserved in an explosion, the kinetic energy of the system most definitely is not. It increases. This interaction, one object becoming many, with an increase of the kinetic energy of the system, is called an explosion. The second type of collision is inelastic. The second possibility is the reverse, that two or more objects collide with each other and stick together. Thus, after the collision, forming one single composite object. The total mass of this composite object is the sum of the masses of the original objects, and the new single object moves with the velocity dictated by the conservation of momentum. Although the total momentum of the system of objects remains constant, the kinetic energy doesn't, but this time the kinetic energy decreases. This type of collision is called inelastic. The last type of collision is elastic. If two or more objects approach each other, collide, and bounce off each other, moving away at the same relative speed at which they approach each other. In this case, the total kinetic energy of the system is conserved. Such an interaction is called elastic.